cool. So now we get to do some fun stuff. And let's take a look at how do you build a TCP server. So we got package net, and we also have ports. And ports are places where things come in and go out of your computer. So you can look at this list right here, Wikipedia, and you can see some of the well-known used ports. So like here's port 80, right? HTTP, right? So that's the common port for like doing web stuff. But we'll be using like higher up ports that aren't used. You can see these numbers. How high do they go? Like what's 9,000? 9,000 is often used, or 8080. 9,000. But 80, is a common one for web stuff.
Your computer will usually block you from starting up something on port 80 due to it being reserved for web servers.
So here we have func main, and we do the package net and listen. So we're going to listen, and we pass in that we're doing this TCP, and we're doing it at port 9000. And then we close that down there, and then we put this loop here, and we accept any requests, and we write a string to connection. And when we do all that, we could go to another terminal, and we could use telnet to connect to this location. And this is listening, and we're connecting, and then it'll write back to us, "Hello world." So and to get out of the program, you press Control-C. So let's see that in action. Which WebStorm takes a while to load up. So while it's loading up, I'll show the next one. So that first one is listening. And so here we're doing a dial, and that dial and TCP localhost 9000. And so we start one terminal where we're listening, and then we go to another terminal, and we can contact this first one, and we could get the response back, right, from this one. So listen is listening for requests, and dial allows somebody else to. That's not making sense. I'm not explaining that right. We have two separate programs running, and they're communicating over TCP. So let me bring this up, and we'll just take a look at it here. All right. So change directories 41, 02. So when I run this one, I can now go to my other terminal and telnet localhost 9000. And it printed back to me, "Hello world," and then connection closed by foreign host. So how did that work? What's happening there? Maybe if we look at this documentation, you can see a little bit more. So we could click on net listen. And there's listen announces on the local network address, local address. So it listen announces on the local network address. And the network net must be a stream-oriented network, TCP, TCP4, TCP6, Unix packet. See dial for the syntax of listen address.
So listen basically tells the OS, reserve this, I'm going to be using this.
So it listens, and then a request comes in. And let's see what listen is returning. listener, listen Unix. There we go. The same thing here, returns a listener and an error. And this is the listener type interface, accept, yeah? I'm off the top. Is that better? So listen returns a listener and an error. And so here's listener. And a listener has accept and close and address. Address returns the listener's network address. Close closes the listener. And accept waits for and returns the next connection to the listener. And we have a connection and an error. So we can look at connection there and see what that is. In connection here we have read and write. Right? So read and write, those are our reader, that's our reader interface, and that's our writer interface. So we have, this connection on accept gets returned, and we need to close a listener. A listener needs to be closed. And so when we look at our code, now listen, this is the listener, and then we have to close the listener. Right? So defer there says, okay, when this function's all done, we're going to close that. And then we have for, and so this is continually looping, and it's listening to accept. And if we go back to that code there, listener needs to accept, and then it'll return a connection and an error. And so we have a connection and an error right there. And then we use IO write string, and we're writing to a connection. Connection, can we write to a connection? Because a connection implements the reader and the writer. We can write to connection, so we have the connection there. And what we're writing is format sprint, right? So string printing something here. So we can look at IO write string and see what that does. So let's look at godoc.org/IO. I'm not sure if it's IO or IO write string. Write string. There we go. And write string takes a writer and a string. And since connection is both a reader and a writer, it implements the writer interface, and this takes a writer interface, so we could put the connection there, and we could write to that. So that takes a writer, and we need to pass in a string. Write string writes the contents of string S to W, which accepts a slice of bytes. If W implements write string method, it is invoked directly. So here we're just format printing our string, hello world, new line, and then the time, and a new line. And then we close it. So we start listening, and that gives us a listener, and then we have to close the listener, and the listener has an accept function. An accept function returns a reader and a writer. And we could use write string to write to that. And then it takes the writer and then the string. And then that writes it out. And then we close our connection. Let's look at dial. So down here, Control C, and I close that program. So I started this one and crash. So let me try this. Go back to 02. And I'm going to run this one.
You can see right here, connection refused.
Yeah, connection refused. I'm going to go back to my 02 one, and I'm going to listen with 02. So now 02 is listening. And I'm going to, this last time 02 is listening, I telnetted in this way, right? But now here I'm going to go to, where am I at? Documents, go, source, yeah. So So now I'm going to run the dialer, and I'm going to dial in. And when I dialed in, as a client using dial, the listener said, oh, hello. Right? So I was able to dial in one way, right? The listener was listening, and I was able to use telnet to connect to the listener, and then it closed it. Or I could have created a dialer that dials some location and makes a request. So let's see how the dialer works. So here we have net.dial. So just right off the bat, let's go look at dial. And wow, quite a bit of information there. I'm going to go to the documentation. Even though it'll be the same, it'll be formatted different. So net. Dial. Just look at my different choices here before I commit to any one. Dial connects to the address on the name network. Known networks for TCP, UDP networks. Examples, connect using TCP, this place. For IP networks, and what's it return? A network and an address string. Or it takes that and returns a connection and an error, sorry. And then the connection, the connection is the reader-writer again, right? So let's see how do we use it. So here we have net.dial and TCP, and then where we want to dial. Returns a connection, and then we're deferring closing the connection, and then we use IOUtil readall, and we pass in the connection. That returns a slice of bytes. And then we print line that slice of bytes, and we convert it to a string. So let's look at what IOUtil readall does. IOUtil readall. So readall takes a reader, returns a slice of bytes, reads from R until air or into file. So basically it reads everything. But returns a slice of bytes and an error. And it takes a reader. So here we're seeing the power of interfaces because connection implements the reader and the writer, right? We have a connection, and then it's a reader, so we could pass that into something that takes a reader. And that's IOUtil readall, and that reads everything, returns a slice of bytes, and then I could convert that to a string. It's a conversion, not an assertion. Assertion is only for what? What? What's assertion for? Only for interfaces, right? Does everybody know what that would look like if I didn't do the conversion? You raise your hand, you know what that would look like if I didn't do the conversion. Yeah. So let's see it. Take off the conversion. I'm still running here, so I could probably just run this again. And there it is, slice of bytes. And if I was to look at that slice of bytes, right, the first time it printed hello world. Well, there's a lot more in there than hello world, I think. It also gave me date. That's what it is. So capital H is 72, I bet. Lowercase e is 101. L, 108. L, 108. O is 111. Space, 32. What's that?
Between 70 and 120 letters.
Yeah. So I can put this back to conversion of string, run it again, and I see that. Where are my slides? So that's both a TCP server that listens and one that can dial in. So you start the listener, and then you dial in. And we're having two separate programs running, and they're communicating over TCP. That's like the unique thing. We're not communicating here over HTTP. And so here is kind of that stuff I was showing you before, right? Where how we get to that and how the interfaces play a part in that. So you're going to create an echo TCP server. It should accept a connection and write to the connection anything that's sent to it. So let me just show you that running. And again, that code is on GitHub. How do you like this class? Homework where you're given all the answers. We talked about that last week, right? Or 2 weeks ago. That's no different than real life. Get it from me or get it from somebody else. Change directories. Where am I? 41 and then 04. VO1. All right, so I'm running this one. It's listening, TCP on 9000, defer the listener close, right? For connection, we're going to accept anything that comes in, and it'll create a connection, which is a reader and writer. And that's just going to always be running. And where's that close? Right down there. And so we'll close that right before we leave. And then we have in here another loop that just keeps running. And this loop makes a slice of bytes, 1024, gives me a byte slice of a certain size. And then we do the connection, and we use .read byte slice. And that gives us back in and air. So we can look and see what that does. And we also have connection write byte slice. And that gives us, and we're writing just, however many bytes we received. So up to n, right? The length that was read was n. And here we're writing just like from 0 to n, not including n, right? And so when we look at this, how this is running, I could go back to here and do telnet localhost 9000 and connect to the localhost. And so now I could echo. Whatever I type in, it comes in, right? It's listening, and then it accepts the connection, creates a connection, and then it reads it, and then it immediately just writes it back out. So there's a couple of ways you could implement that. So this is one way you could implement it right here. You could use a scanner. So in this first way, we did read and write. In the second way, scanner, buff.io scanner, so read a line at a time. And the third way, we could do copy. So copy just takes, let's go look at copy. Takes a writer and a reader, destination and source. I seem to remember hearing somewhere that, often when you have this, it's destination source in that order in a lot of different places in Go. Copy buffer, destination source.
Probably to make it match with the assignment to a variable.
Yeah. So create an echo server, that's the one thing in there. And you got the code, but kind of interesting. That's it. Daniel, you got anything you want to share? Or any commentary you want to provide on that?
I believe Telnet is tricky to get to work on Windows, but there are
Yeah.
Telnet apps for the phone, which is probably the easiest way to get it going. Mac and Linux, it should just be built in and working properly.
Nah, that's simple. Only a click, 2 clicks.
If you can find it.
Oh yeah, you right click.
Anybody have any questions or comments? Yeah.
For the listening function, the documentation, I believe, said that that was only for TCP. What about for UDP? What do we use there?
It's for both TCP and UDP. The first argument is a string. You can pass in TCP or UDP.
Right, but I think in the documentation it listed only TCP, TCP4, and TCP6.
It had
I didn't see UDP on there. I don't know if we can look at that again.
had like
I know I saw for dial, I saw the UDP options.
All right, I'm just trying to go there. So network stream must be stream-oriented network, TCP, TCP4, TCP6, Unix, Unix packet. And gives us a listener.
Yeah, that would be stream-oriented. So yeah, there would be something else to do for UDP. I believe it's still in this net package. I believe it's got a listen UDP function, which takes slightly different arguments, because UDP has a few extra options like broadcast, which are not available for TCP. And then TCP is also a stream-oriented, as in it's almost like a pipe. You push stuff in, it comes out same order on the other end. Whereas UDP is more like a mail system. You make a package and you send the package. So there has to be some differences in how it's done. So yeah, here's the listen UDP function here, which will give you back a UDP connection as opposed to just a generic connection.
Cool.
Odd that UDP has its own dial function, but the generic dial also accepts UDP as an option.
Yes. There's a TCP connection style stuff too.
Okay.
The generic dial will just figure out which one to use.
Okay.
So whenever possible, though, you should use TCP. It's you don't have to worry about losing data. You have to worry about data arriving in the wrong order, and a lot of routers, firewalls are optimized for TCP, and will give you a lot less headaches.
How would you explain, just in your own words, the difference between TCP and UDP? Anybody?
TCP can guarantee that the data that you want to send will get there.
Okay.
UDP cannot.
Connection-oriented connection is.
Say that again.
TCP is connection-oriented. We establish a path before sending the data, and UDP there's no connection, right? Internet. So we don't establish a particular path, specific path. So it goes to like different routes, and TCP follows the same route.
I might consider something similar to an analogy of a telephone call and text messages.
Yeah.
You got TCP, which is be similar to an actual telephone call. You got a connection data that's going back and forth. And UDP, which is close to a text message. You write your message, you send it.
It's interesting that HTTP is like used by other protocols, right? HTTP uses TCP, which I've always heard about, but if TCP is the one that maintains the the phone call connection, I don't think of HTTP as maintaining connection. You have to go to TCP to do that. So even though HTTP uses it, it doesn't do that, right?
Yeah, HTTP is using TCP mostly for the guaranteed arrival order, guaranteed arrival and guaranteed order. It doesn't need the maintained connection so much. Although some web browsers will keep the connection open for if it needs to make rapid HTTP requests. Like, for example, going to this web page, it had to grab the entire HTML document, and then it had to grab each picture individually, so it could use the same TCP connection for all.
All right, what would you guys like to see? Anything else? Got enough to go on?